So in this stage, we will need a JK flip-flop connecting with the start-stop button and the reset button. When we press the start-stop button, the signal will be sent to J input, K input, and the clock. When we press the second time, the clock will be turned off, and also we can turn off the clock with the reset button. In this stage, we will need to build a counter with 4 JK flip-flop. We need to remind that the trigger attribute of each JK flip-flop be turned to the falling edge so that the number will count up. And also we need to ensure that the number will count from 0 to 9. To do that, we will need to connect the second and the fourth JK flip-flops output to an AND gate, and the output of the AND gate connect to each JK flip-flops reset input. Also, the OR gate here is to ensure that the reset button signal also can come to the counter to reset the number. When we press the stop button, the counter should work like this. And we press stop, the number will stop count. And when we press the reset button, the number will be set to 0 and the clock will turn off. In this stage, we first need to build a counter with 3 JK flip-flop and 1 constant value 0. We also need to ensure that all the JK flip-flop attribute trigger need to be turned to falling edge, and to ensure that the number only count from 0 to 5, we need to connect all the input of each JK flip-flop to an AND gate, and the first JK flip-flop output signal need to be sent through a NOT gate first before going to the AND gate. The AND gate output will be sent to the reset input of each JK flip-flop. We also need to build the OR gate and the reset button like in stage 2, so that the reset button signal can go to the counter as well. Now the counter should work like this. At this stage, we need to build 2 counters, and in each counter we have 4 JK flip-flop with their attribute trigger be turned to falling edge. Also, we need 1 AND gate and 1 OR gate for each counter, and they will be built like in the second stage. When we have done, the minutes should count to 9 and 9, like this. The minutes will count to 99, and when we press again, the number should stop counting, and when we press reset, all the number will return to 0, and the clock will stop. First, we need to connect the output of each JK flip-flop to its corresponding key flip-flop like this, and we will do that until we reach the number of 16 key flip-flop. And for every 4 key flip-flop, we will connect their output to a splitter, and the splitter will connect to a hexadecimal displayer like this. After that, the splitter should work like this. When we press the reset button, all the elapsed time and the speed time return to 0, and the clock will stop. For this stage, we need to implement 4 more speed time decoder like this, and each of them work like in stage 5. Now when we press the split button, the first value will be stored here, and when we press the second time, the value will be moved to the second speed time decoder, and the new value will be displayed here. We can do that up to 5 times. When it reaches 5 times and we press the split button more than 5 times, the oldest value will be removed to make room for the new one, like this. When we press the reset button, all the speed time will be reset to 0, like this.